is Saritha, working as assistant professor in the Department of PCE, Institute of Aeronautical Engineering. So today's session I am going to explain about some example problems on adjacency, path and connectivity. So in this topic, adjacency, connectivity, path, these all comes under relationship between pixels. So pixel is nothing but it is a picture element. So in this we are having different types of relationships are there in between pixels: connectivity, neighborhood, adjacency and path. So in this neighborhood operation, we are having x plus 1 comma y. So when we go for this neighborhood operation, we are having three types: n4 of p, 4 neighbors; nd of p, it is in diagonal form; n8 of p. n8 of p is nothing but n4 of p union with n8 of p. n8 of p. In this nd of p, it is nothing but n8 of p. In this case, how we'll get relation between this n4 of p and nd of p and n8 of p means, consider plus minus in x and y coordinates here. In this case here, from this side, this is x plus 1. What is the next pixel? That means point. So point we are representing p of x comma y. What about next pixel? We are representing x plus 1. Here it is plus only in positive. X plus 1 comma y. So when we go for this side, x comma y plus 1. This side, x minus 1 comma y. Here y minus x comma y minus 1. So this is nothing but n4 of p. n4 of p. In this n4 of p, we are having two vertical and two horizontal neighbors are there. Two vertical and two horizontal neighbors are there. This is the center point p of x comma y. It consisting of two vertical and two horizontal neighbors are there. Here we are representing x plus 1 comma y, x comma y plus 1, and here x minus 1 comma y, here x comma y minus 1. When we go for in diagonal form, in diagonal, so this is one path. So here it is one diagonal quadrant. So here it is q3, here it is q4. In this case here, this one is x is plus, y is plus. What about next? X plus 1 comma y plus 1. So when we go for in this point, for this quadrature here, x minus 1 comma y plus 1. From this side, x minus 1 comma y minus 1. Here x plus 1 comma y minus 1. Here this is y is minus, x is plus, then x plus 1 comma y minus 1. Here x plus 1, here x is plus and y is also plus. Then we are writing x plus 1 comma y plus 1. From this side, x minus 1. Here this one is in x axis, it is minus, and here it is plus. Then x minus 1 comma y plus 1. From this side, here x is minus and y is minus, then x minus 1 comma y minus 1. So here p of x comma y, this side is x plus 1 comma y plus 1. Here x minus 1 comma y plus 1, x minus 1 comma y minus 1, x plus 1 comma y minus 1. So these four are in diagonal form. It is representing nd of p, and these four are n4 of p, neighboring pixels. So joining of these two, n4 of p union with nd of p is nothing but n8 of p. So how will get the connectivity? Any two pixels are linked together. Any two pixels are linked means, if those pixels are neighboring pixels or adjacent pixels, and the gray levels are specify some specific criterion. So specify for some specific criterion, then here the gray levels are specified for some specific criterion. So here we are representing, if we go for neighbors, so this is pixel 1. So pixel 1, here the gray levels are same. Then if the use of, for example, consider here n4 of p. Consider here n4 of p. n4 of p here, which pixels are same here? For example, consider here b of 1. So, which pixel values are 1? Which pixel values are 1? So, we can find the path in that pixels only. So, here this is 1. From here to here, it is n4 of p. When we are applying n4 of p means we need to consider either left side or right side, top side and bottom side. So this is center pixel. This is center pixel. So in left side pixel is also has adjacency. This pixel value is also same gray level for some specified in some specified criterion. So here this is 1. So when we go for a next path from this side, in left side it is 0. It is not possible. So this here it is 1 only. So it is adjacent pixels and this side is 1. So it is adjacent pixel and this side is in upside. This is also adjacent pixels. This is nothing but this path is nothing but neighboring of pixels. So it is n4 of p. n4 of p. Here also this is nothing but n4 of p connectivity. n4 of p connectivity. If we go for n8 of p, if we go for n8 of p, when we go for n8 of p means either we can choose in diagonal form, and adjacent neighboring of pixels. So when we go for n8 of p, this is point means we need to, this is neighboring pixel, this one is neighboring pixel, this one is neighboring pixel, this side is neighboring pixel. If you are having, so it consisting of, so this is point means p of x comma y means when we go for n8 of p, we need to choose path from this word left side, top, bottom in diagonal form also. This side, this side, this side and this side. But when we go for n4 of p means we need to consider only top, bottom or right side and left side. This is for n4 of p. When we go for nd of p, nd of p means we can choose diagonal path only, So this is for neighboring of pixels, n4 of p, nd of p and n8 of p. In this, what is mean by path? Path is we are representing the pixels in digital path or curve from pixel p with coordinates x0, comma y0. Here the pixel q with coordinates xn, comma yn. So p and q. Here the points p x0, comma y0, x0 and y. Here xn and yn. This is my starting location and how to reach. This is starting is x0 and y0. Here xn and yn. When x0 y0 equals to xn yn means both are equal means it is a closed path. So in this coordinate is a sequence of distinct pixels with coordinates x0, y0, x1, y1 and up to xn, yn. So here the adjacent pixels are xi, yi. So xi minus 1, yi minus 1. So in this case, if x0, y0 equals to xn, yn both are equal, it is a closed path. So we can define 4, 8 and m path based on the type of adjacent used. For example, this is point P, this is point Q. So I need to find the path from P to Q. So how we can find the path from P to Q? How we can reach from source to destination? With the use of either 4 adjacency or 8 adjacency or m adjacency or mixed adjacency. M is nothing but mixed adjacency. Based on these 3 paths, we can reach from source to destination. We can travel from point P to point Q. Here consider one example here. Adjacent and path v equals to 1 comma 2. V equals to 1 comma 2. We can travel from, this is for example, this is point P, this is point Q. Which pixels are, how we can find the path means the adjacent pixel values. The adjacent pixels are, the values are 1 or 2 only. The adjacent pixel values are 1 or 2, we can choose that path only. We can choose that path only. So here, for example, I have 4 path and 8 path, M path is there. So when we go for path 4 means in that we need to consider top point, right side, left side and bottom side. This is my point P. From this point, if I am using 4 adjacency, if I am using 4 adjacency, is there possibility? Is there any possibility? Here we have mentioned V equals to 1 comma 2. V equals to 1 comma 2 means we are finding the path from P to Q. The whose pixel values are either 1 or 2, we can choose that path only. But here, when we are applying the 4 adjacency, here in this, how many possibilities are there here? This side, this side, this side and this side, top side and left side. So top side is 0 and left side is also 0. There is no path. But diagonal is possible. But in when we go for 4 adjacency, diagonal is not possible. Diagonal we can go with either top side or left or right and bottom. So 4 adjacency is not possible. So what about 8 adjacency? What about 8 adjacency? In this 8 adjacency, we are using 8 adjacency top, bottom, left, right, and this diagonal form also. We can choose either any one path. So in this case, here up to here, from here to, we are having 2 paths. One is this path, another one is this path. So we can choose either any one path. So in this, with the use of this adjacency, we are getting multiple paths. So to avoid this multiple paths, we can go for M adjacency. We can go for M adjacency. So in this M adjacency, N4 of P intersect with NQ of Q. N4 of P intersect with N4 of Q is equal to null. Is equal to null. Then we can choose that path only. So with the use of M adjacency, the path is this one only. So this is the basic example how to find the path. How to find the path from P to Q and with. So observe here. In this 4 adjacency is not possible and 8 adjacency, this from 1 to 2 and 2 to 1 and 1 1. So this is the 8 adjacency, and when we go for M adjacency, from here to here, here to here, this is the M adjacency. And here in this example, 0 1 1 0 2 0 0 0 1. In our image processing, the image are representing in the form of matrix only. So here the representation here 1 comma 1, first row first element, and first row second column, and first row third, and here second row first column, second row second column, and here second row third element. So like that we are representing 1 0 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. So here when we go for 8 adjacency, how many paths are there? Total 2 paths. Total 2 paths. So one path, this is from starting path here 1 comma 3. This one is 1 comma 3. Here it is 3 comma 3. So how to the path from 1 comma 3 to 3 comma 3. Here first one is 1 comma 3 comma 1 this point is 1 comma 3 comma, this one is 1 comma 2, this point is 2 comma 2, and this point is 3 comma 3. Here the first path, first path is 1, 3, and next one is 1, 2, and next one is 2, 2, and next one is 3, 3. And what about second path? Second path is 1, 3, and 2, 2, 3, 3. So this is 8 adjacency. This is 8 adjacency. When we go for n adjacency, here it is 1, 3, here 1, 2, this one is 2, 2, here it is 3, 3. So reach from one path from 1, 3 to 3, 3, here 3, 3, here 1, 3, and 1, 2, and 2, 2, 3, 3. Here, so this is for M adjacent, and this is for 8 adjacent, and this one is M adjacent. So in this arithmetic and logic operations here, addition is nothing but P plus Q, subtraction P minus Q, and multiplication we are representing P and Q, division is P by Q, and it's a logical arithmetic operations. And logical operation, when we go for logical operations here, AND operation, OR operation, and complement operation. Here point P and point Q, when we go for addition, adding of these two, P plus Q, and subtraction we are representing P minus Q, and multiplication P into Q, division we are representing with P divided with Q, and logical AND function P and Q, OR function is AND function is nothing but OR is nothing but addition here, and NOT means it is complement function. Complement, for example, if Q value is 1 means with the use of complement it is 0. If it is 1 means, if it is 0 means here it is 1. This is the complement arithmetic and logical operations. And here, if the following arrangements, so in this following arrangement of pixels, the circle point is part of the boundary of the one valued pixels if 8 adjacency is used. If 8 adjacency is used, true or false. Here 8 adjacency is used. It is true or false means in this case, here this is center pixel. So here with the following arrangement of pixels, the circled point. So the circled point is part of the boundary of the one valued pixels if adjacency is used, true or false. In 8 adjacency point, so in adjacency we are using, these are the points. So in this point, here in 8 adjacency, this is neighboring pixel, this one is neighboring pixel, this one. Here one valued pixel means whose pixel values are 1. But what about this pixel? This pixel value is 0. Means it is a 8 adjacency. It is true or false? It is not a 8 adjacent. It is a false condition. So we are considering this one. In this case, 8 adjacency means we can choose either N4 of P and N8, ND of P. We can choose either in top, bottom, left side, right side, and diagonal form also. In this case, this one is not this here. This pixel value is 0. But in our question, it is one valued pixel. It is not possible. So here it is a false condition. It is 8 adjacency is not possible here. So in this case, in the following arrangement of pixels, the circled point is part of the boundary of the one valued pixel. For adjacency is used. It is true or false. So in this for adjacency, when we go for adjacency here, this is for adjacency. When we go for adjacency, one. So right left side, right side, top and bottom. Top and bottom. Here left, right and top and bottom. So here it is true or false, it is true only. So with the use of 4 adjacency, it has 4 neighboring pixels with the values of 1. So here the value is 1. 1 valued pixels. 1 valued pixels. And in this question, in the following arrangement of pixels are the two regions. So two regions of one adjacent. Two regions of one adjacent means if you are using this one here, this is region 1 and this is region 2. So 8 region means we are having point, this is center point means 1. So here 3, so total 9 pixels. So this is one region and here it is also one region. So this is region 1 and this is region 2. So this is the arrangement of two regions. Here it is also with the use of 4 adjacent. Here it is also in the following arrangement of pixels or the two parts. So one's adjacent, if 4 adjacency is used, 4 adjacency is used. So 4 adjacent is used means here it is also possible. When we go for in 4 adjacent, here 4 adjacent means left side, right side, left side, top and bottom. Top and bottom. So in this case also it is, so center pixel top, left, right and bottom. Here also top, left, right and bottom. So it is one part and this one is one part. And in this example, consider here in the following arrangement of pixels, the two regions of ones are disjoint if 4 adjacency is used. So 4 adjacency is used means, 4 adjacency means, observe here. So in this 4 adjacency, when we go for 4 adjacency, it is path and here it is also one path is here, here. So from here to here, here to here, from here to here, here. From here to, from this one to, is there any possibility? Here there is no possibility. But from this point, this is one also neighboring pixel, this one also neighboring pixel, this one also neighboring and this one also neighboring pixel. But between these, between this point to this point, there is no link between two pixels. So means here disjoint from this region to this region. Here it is region 1, here it is region 2. And here consider the image, one example here. Consider the image segment shown in figure. Let v equals to 0, 1 and compute the lengths of the shortest 4 path, 8 path and m path between pixels p and q. If any one of the path not existed, explain why. So in this question, let v equals to 0, 1. V equals to 0, 1 and compute the lengths of the shortest 4 path, 8 path and m path between pixels p and q. Between pixels p and q. So which path is existed, which path is not existed? Explain clearly means in this image here v equals to 0, 1. So which pixel values are 0, 1? We can choose that those pixels only from P to Q. So find the path from P to Q. Which pixel values are 0 and 1? We can choose that path only. So in this consider for example 4 adjacency. 4 adjacency. So with the use of 4 adjacency, this is point P, this is point Q. In this point P to Q, here how many zeros and ones? Here the adjacent pixels are 0 and 1. We can choose those pixels only. Here how many possibilities are there? This one and this one. In 4 adjacent. In 4 adjacent, this one and this one. So from here, is there any adjacent pixels? This side is 2. This side is 2. It is not possible. This side is also not possible. Again, go to this pixel. In this pixel, how many possibilities are there? Only here, this side is 2 means this is not possible. In right side, it is 1. It is possible. It is possible. So from this pixel, how many possibilities? This side is 2. This path is not possible. And this top side, it is 1. So up to here, it is okay. From this side, from this pointer, right side and top side. So if we choose right side, from this point to, is there any possibility? Here it is 2. So this path is not possible. So from 1 to 0, here, from this 1 to 0, is there possibility? Is there possibility? There is no possibility. In this case, a 4 adjacency is existed. Here it is not possible because the point Q, it is in diagonal pixel of this point. So diagonal, these two relations are in diagonal. So this path is not existed. When we go for 4 adjacency is not existed in this problem. So here the path from here up to here only. So there is, so from here to point Q, there is no path. So 4 adjacencies not existed. Here when v equals to 0, 1, 4 path does not exist between P and Q because it is impossible to get from P to Q by traveling along points that are both 4 adjacency and also have the values from figure A shown in condition. Here, observe here. In this case, this is point P, this is point Q. Up to here, it is okay. From here to here, it is in diagonal form. It is in diagonal form. There is no path from this point to this point. So, 4 adjacencies does not exist. So, when we go for 8 adjacency, here in this 8 adjacency, this is 1. And here this possibility and this one. So this possibility 0 to 1 and 1 to 1 and 0 from here. So these here from 8 adjacency. So these lines. So when we go for the straight lines are. The straight lines are 8 adjacency here. In this case, 1, 0 up to here. How many paths are there? This is one path and this one is one path. So from here to here, 1. From here to here. So when we go for M adjacency, from 1 to 0 and 0 to 1, 1 to 1, and this is one path. So in this example, 8 adjacency and M adjacency both are M adjacency and 8 adjacency are existed. So in this, the shortest path, the length is 4 for M adjacency. When we go for 8 adjacency, the dashed line we are representing the 8 adjacency and straight line we are representing the dashed line we are representing the M path and the straight line we are representing the 8 path. Then what is the distance from here? 1 to 0, 1 distance. Here 2, this one is 3, 4, 5. So when we are using M adjacency, here it is for when we are using M adjacency, here path value is, here it is only 5. So with the use of 8 path, 1, 2, 3, 4. Here with the use of M adjacency, here it is 4 only. Here it is 4 only. So 4 adjacency is not existed. Here M adjacency existed and 8 adjacency is also existed. With the use of M adjacency, the distance is 4 only, and with the use of M adjacency, the distance is 5. And one more problem here, consider the two regions S1 and S2 shown in figure. Here V equals to 1. Determine whether these two regions are 4 adjacent, 8 adjacent or M adjacent. So in this example, this is point P, this is point Q, this is point P and this is point Q. In this, 4 adjacencies existed. So here point P to point Q, here the relation is in diagonal form. It is in diagonal form. Means 4 adjacencies not existed. What about 8 adjacency and M adjacency? When we go for 8 adjacency, we can choose in top, bottom, left, right and diagonals also. Here this point P to Q, it is in diagonal form. So in this case, 8 adjacency is existed and M adjacency is also existed. So in this solution, S1 and S2 are not 4 connected because Q is not in the set of N4 of P. N4 of P means we need to consider only top, bottom, left, right, not in a diagonal form. But P and Q both are in diagonal form. So this path is not existed. And S1 and S2 are M connected. So S1 and S2 are M connected. Q is in ND of P and the set of N4 of P intersect with N4 of Q is null only. So here when M adjacency path is existed means here N4 of P intersect with N4 of Q is empty. At that condition M path is existed. And 8 path is S1 and S2 are 8 connected because Q is in the set of N8 of P. Here, so this is point P, this is point Q. So this is for M adjacency and 8 adjacency. And adjacency, 2 pixels are adjacent if they are neighbors and their intensity level V satisfy some specific criteria of similarity. So if your 2 pixels are adjacent, so 2 pixels are adjacent means consider the diagram. If 2 pixels are adjacent, if they are neighbors, 2 pixels are adjacent if they are neighbors and their intensity level V, the intensity level V satisfy some specific criteria of similarity. If 2 pixels are adjacent, means if the pixels are neighbors either in diagonal form or neighbors of pixels and their gray level values also satisfy some specific criteria. Here V equals to 1. Example, V equals to 0, 2. So binary image we are representing 0, 1. So grayscale we are representing 0, 1, 2 up to 255. In this case, in binary images, 2 pixels are adjacent if they are neighbors. 2 pixels are adjacent if they are neighbors and have some intensity values either 0 or 1. 2 pixels are adjacent pixels. 2 pixels are adjacent pixels means if they are neighbors and have some intensity values either 0 or 1. In the grayscale, image contains more gray level value in range 0 to 255. So in this example, consider the image segment shown in this figure. So compute length of the shortest 4 and shortest 8 and shortest M paths between pixels P and Q where V equals to 1, 2. Here the pixels of the matrix arranged here 4, 2, 3, 2, 3, 3, 1, 3, 2, 3, 2, 2, 2, 1, 2, 3. So in these pixels P and Q, where B equals to 1, 2, which pixel values are 1, 2, and here the point P and point Q. So how we can find the path from P to Q? Whose pixel value, whose adjacent, if adjacent pixel values are 1 or 2, we can choose that path only. So in this condition, four adjacencies is possible here, shortest. So from this point, if we are considering this, how many possibilities are there if we are using 4 adjacency? This one and this one. So from here to this one, and from here to this one, and from here, what are the possibility? This is one possibility, and this is one possibility. This is one possibility, and this is one possibility. From here to Q, from this point to point Q, is there possibility when we go for in 4 adjacency? It is not possible because of these two pixels are in adjacent. These two pixels are in diagonal form. So it is in diagonal form. But when we go for 4 adjacency, diagonal form is not possible. So in this example, 4 adjacent is not existed. So here, from here to this point to this point, this point to this point. So this is 4 adjacency. So when we go for 8 adjacency, is there possible here? This is point 2, this is point P. Here in 8 adjacency, this is one way, this is one way, in diagonal also. But what is the question? In our question, B equals to 1, 2 only. But here the value is 3. So it is not possible. So here, from here to here the value is 3. It is not possible. From here to here, it is also not possible. So next come this point. So come to this point. So this is 1. From this point, here in top side it is 3. This path is not possible. And this side it is 2. So it is possible. So from this point to top side is one path, and this side is 1. This side is value is 3. This pixel value, the adjacent pixel value is 3. So this path is not existed. From here to here, is there possibility? So is there one possibility? So this point to this side is 2, and this side is 1. In diagonal form is 3. This is not possible. If this path is possible, then whatever this from this point to here it is 3. It is not possible. There is no other option. Then point 1 to point 1 have 3 means this is not possible. Only the way is 2. So here, what is the shortest path? If we are choosing this path, here it is 1, 2, 3, 4, 5. Here the distance is 5. So with this path 1, 2, 3, 4. Here it is 4. If we are choosing this path, here it is 4. So shortest path is 4 only. So in this point, this is point P, this is point Q. With the use of M path, here also same conditions, this side and this side. So from this point to, is there any possibility? It is also not existed. From this point to, this path is there, this one is there. But in our question, in our M adjacency, one condition is there. N4 of P intersect with N4 of Q. N4 of P intersect with N4 of Q. It equals to pi, means null. Then M path is existed. But here when we are going to choose this point, here common point is this path is there. So for that case, ignore this one and we can travel this path only. So what is the distance with the use of M path? 1, 2, 3, 4, 5. So with the use of M path, here this one 1, 2, 3, 4, 5. So in this session, what is meant by pixel and what are the relationship between pixels here? N4 of P means we need to consider left, right, top, bottom. And D of P means we need to consider in diagonal form only. And N8 of P means N4 we need to consider diagonal form, right, left and bottom side. So this is N8 of P in emergency, 4 adjacency and 8 adjacency. How we can find the shortest path from point P to point Q. So here we need to remember one point. When emergency is existent means here the condition is N4 of P intersect with N4 of Q equals to null. So we need to consider this path. When these values equals to null, so we can use M path. And here in M, when we go for M path, we are having multiple paths. To avoid this multiple paths, for that case, we can go for M path, M adjacency. So these are the example problems based on a relationship between pixels. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.